Today in geometry, we are looking at section 12.2, which is surface area of prisms and cylinders. We're also going to learn about what's called an apothem. Right, so we'll start out with some vocabulary. So first, a prism is a polyhedron with two congruent parallel faces called bases. The other faces are called lateral faces. They are parallelograms formed by connecting the corresponding vertices of the bases. The segments connecting these vertices are lateral edges. Prisms are classified by the shapes of their bases. So we're going to look at a few examples of some prisms. So this first one, I'm going to shade the bases. So there's my top base and my bottom base. The shape of that is a pentagon. So this is a pentagonal prism. We look at the next shape. Again, the base, the top, the bottom. The shape of this is a hexagon. So this is a hexagonal prism. Our next one, the top, the bottom. Those are rectangles. So this is a rectangular prism. And our last one, I have a triangle at the front, a triangle at the back, so this is a triangular prism. So you see that we can have lots of different shapes of prisms. All right, so first the lateral area, which we will abbreviate with LA of a polyhedron, is the sum of the areas of the lateral faces. So the lateral area does not include the bases. That's extremely important. So then we also have what's known as the surface area. We're going to abbreviate that with SA. This is the sum of the areas of all the faces, which includes the bases. Okay? So first, let's look at the lateral area of a prism. So this is our formula. LA is equal to capital P times H, where capital P is equal to the perimeter of the base, and H is the height of the prism. Okay? So the height of a prism is the perpendicular distance. So remember, height is always perpendicular. Perpendicular distance between the bases. In a right prism, each lateral edge is perpendicular to both bases. So our lateral edge, okay, this is a lateral face. So the lateral edge is perpendicular to both bases, top and bottom. So that is the height. Okay. A prism with lateral edges not perpendicular to the bases is referred to as an oblique prism. And then I just gave you some examples here. So we have a right rectangular prism, so perpendicular. Oblique, you see that the height, this is not perpendicular to the base, not perpendicular. A right triangular prism and an oblique. So in an oblique, the height gets dropped on the outside. So here my height would get dropped on the outside. All right, so the formula for the surface area of a right prism. The surface area is equal to 2 capital B plus PH, or AP plus PH. Well, capital B stands for the area of the base, and so depending on what shape your base is, that's going to change. Capital P is the perimeter of the base. A is the apothem of the base, and we're going to talk about the apothem here in a little bit. H is the height. Recall that lateral area is the perimeter times the height. So basically, your surface area is your lateral area plus 2 times capital B, because B is the area of the base, and each prism has 2 bases. All right, so we're going to start out nice and easy. Find the lateral area. So first, what is the shape of the base? So I'm going to shade this in. So there's my top base and my bottom base. So my shape of the base is a rectangle. Okay. So then I can find the perimeter of the base, because remember, perimeter just means add up the sides. So my perimeter of the base, if I do 5 plus 5 plus 6 plus 6, so I get 22 feet is the perimeter of my base. So then the lateral area, our formula says it is the perimeter times the height. So my perimeter is 22. The height here is this 10. So 22 times 10 is 220. My units were feet. Remember, anytime we find area, our units are squared. So the lateral area is 220 square feet. So now we want the surface area. We're going to use this formula. It's the lateral area plus 2 times the area of the base. So my surface area is equal to 220 plus 2 times the area of my base. My base is a rectangle. To find the area of a rectangle, it's length times width, 5 times 6. Okay, so this is 220 plus 2 times 5 is 10, 10 times 6 is 60. So my surface area is 280 square feet. We'll try another one of those. Find the lateral area. Again, the very first thing you want to do is identify what is your base, what's the shape. So here my base are these triangles. So the shape of my base is a triangle. The perimeter of the base, so this side is 8, in the back they tell me that is 6. You can do Pythagorean theorem to find the hypotenuse, or it happens to be a triple, 6, 8, 10. So the perimeter of the base is 6 plus 8 plus 10, which is 24 inches. So then my lateral area is my perimeter, 24, times the height of the prism. So when I'm looking at the height of a triangular prism, I'm not looking at the base, right? So the height of the prism is this 20. So 24 times 20, which is equal to 480 square inches. So then the surface area, my lateral area, 480, plus 2 times the area of the base. My base is a triangle. The area of a triangle is 1/2. Base of the triangle, 8. Height of the triangle, 6. So when I work this out, I get 480 plus, so the 2's cancel. 8 times 6 is 48. So 480 plus 48 is 528 square inches. All right, next we're going to learn about what's called an apothem. Okay? This would have been covered in chapter 11, I believe, but we're doing chapter 12 before 11, so we're going to talk about the apothem. The diagram below shows a regular polygon inscribed inside a circle. The center of the polygon and the radius of the polygon are the center and radius of its circumscribed circle. The distance from the center to any midpoint of a side of the polygon is called the apothem. The apothem is the height of an isosceles triangle that has 2 radii as legs. So if we look here, okay, so first let's just talk about what is our center here. So the center is point A, right? Let's talk about what is a radius. Radius from the center out to a vertex. So here I have AB and AD are both a radius. Notice then that that makes this isosceles triangle. So our isosceles triangle here is triangle BAD. The apothem is the height of that isosceles triangle. It starts at the center, goes to a midpoint of the side of my polygon. So my apothem here in this picture is AC. We're going to come down here and get another vocab word, and then we'll come up here and label that. This is a central angle. A central angle of a regular polygon is an angle formed by 2 radii drawn to consecutive vertices of the polygon. So this right here would be a central angle, because radius, radius. So the angle between them. So here I have central angle BAD. To find the measure of a central angle, you will divide 360 by the number of sides. I want to define the measure of angle BAD here. I have 1, 2, 3, 4, 5, 6 sides. So 360 divided by 6 gives me 60 degrees. Okay? So we're going to practice some with the apothem. So here it tells me that ABCDE is a regular pentagon inscribed inside circle F. So let's just label this A, B, C, D, E. And then we have circle F. Find each angle measure. So first, let's draw apothem FG that is perpendicular to AB. So there's my apothem, and I'm going to label that G. Recall the height of an isosceles triangle bisects the top angle and the base. Okay, so we're going to need that here in a little bit. So if I look, I really have this isosceles triangle AFB. Okay. So the very first thing that they want me to find is central angle AFB. AFB, that is a central angle, that angle right there. So to find that, that is 360 divided by, this was a pentagon divided by 5. So that is 72 degrees. And again, we're just going to write that that is a central angle. Measure of angle AFG. I'm going to draw that triangle out. So this is F, this is G, this is A. Remember that this top angle, all of angle F was 72, but it got cut in half with FG, and FG is part of this. So this is going to be 72 cut in half, which is 36 degrees. Now measure of angle GAF, that's this angle down here. These two together have to equal 90. I just found this one to be 36, so this is going to be 90 minus 36, which is 54 degrees. So now we're going to learn how do we use the apothem in finding area. The theorem for the area of a regular polygon. The area of a regular intagon with side length S is 1/2 the product of the apothem A and the perimeter P. So again, the apothem is the perpendicular, okay? It's the height of that isosceles triangle, but it's from the center of your polygon to the midpoint of any side. And so this is our formula, 1/2 the apothem times the perimeter, or the perimeter is also known as the number of sides times the length of the side. So let's practice that. It says you are decorating the top of a table by covering it with small ceramic tiles. The tabletop is a regular octagon with 15-inch sides. So that's telling me all of these are 15. And a radius of about 19.6 inches. So if I start at the center and I go to a vertex, that is 19.6. If I draw that isosceles triangle, this is also 19.6 because it's a radius. What is the area you are covering? Okay. So our formula is area equals 1/2 the apothem times the perimeter. We can find the perimeter right now. Our perimeter is 15 times there are 8 sides, right? So that's going to be our perimeter. We need to find the apothem. The apothem is the height of this isosceles triangle right here. So I'm going to pull out just the side of that triangle. So this is my apothem. My hypotenuse is the radius, 19.6. The bottom of my little triangle here is half of the 15, remember, because 15 is all the way across. And I dropped the apothem down, which is the height, which cut it in half. So this is 15 halves, or 7.5. This angle up here, I could find that central angle. So remember that our central angle is going to be 360 divided by 8, because this was an octagon, which is 45 degrees. So this entire angle here was 45. But again, when I dropped my apothem, I cut that in half. So this angle is 45 cut in half, which is 22.5 degrees. So now we're going to be using something that's familiar to us. If I stand at this angle, I'm looking for my apothem, which is adjacent to me. I have both of my opposite and my hypotenuse. So I can use SOHCAHTOA. I can use any of them because I have the other two sides, or I could do Pythagorean theorem. So I could say a squared plus 7.5 squared equals 19.6 squared and solve that way. Or I'm going to do SOHCAHTOA because I think it's a little bit faster and I like SOHCAHTOA and I want to review SOHCAHTOA. I'm going to use cosine. So I could say the cosine of 22.5, because that's where I'm standing, is equal to the adjacent side, my apothem, over my hypotenuse, 19.6. So then remember, I just cross multiply, so A is equal to 19.6 times the cosine of 22.5. We want to make sure that our calculator is in degree mode. When we solve this, we are not yet going to round to the nearest tenth. Okay, so here we're going to round to 4 decimal places, okay, because we're not done, and we will round at the very, very end. So when I do 19.6 times the cosine of 22.5, I get 18.1080. Now I'm ready to find the area of that. So the formula, remember, is 1/2 my apothem. I just found 18.1080 times my perimeter, which remember we said was 15 times 8. This is where we can round at the end. Okay? Our final answer is where we'll round to the nearest tenth. So now when I plug all of this in, 1/2 times 18.1080 times 15 times 8, I get 1,086.5 square inches. So that's how you find the area of a regular polygon. We will have those all throughout this chapter. All right, so now back to the lateral area surface area. You're going to see why we needed that, because now they're asking me to find the lateral area and the surface area of this figure. This, okay, I look at how many sides do I have. I have 8 sides, right? So this is an octagon. Each side of my octagon is 8 feet. So my perimeter is 8 times 8, which is 64 feet. So the lateral area is my perimeter, 64, times the height. The height of the prism is 22. So I don't need the apothem to find lateral area. So here my lateral area is 1,408 square feet. I want to find the surface area. I need to find the apothem here. Because remember that my surface area is equal to my lateral area, 1,408, plus 2 times the, it's plus 2 times the area of my base, okay? And so here my area of the base is that 1/2 the apothem times the perimeter. I know my perimeter is 64, so I need that apothem. Okay? So again, I'm going to make that isosceles triangle, drop the apothem down. I'm going to draw half that isosceles triangle. This is the apothem I'm looking for. Each side started out being 8. When I dropped my height, I cut it in half, 4. The central angle, 360 divided by 8, started out being 45. When I cut that in half, that is this top angle, 22.5. I have to use SOHCAHTOA, so I stand here. I have my adjacent and my opposite. So this is the tangent of 22.5 equals opposite 4 over adjacent, my apothem. So this is where we end up having to divide. 4 divided by the tangent of 22.5. And again, I'm not going to round here. I'm going to keep 4 decimal places for my apothem. So I get that my apothem is approximately 9.6569. So my surface area is equal to 1,408 plus the area of our polygon, which was 1/2. But I have 2 of the bases, right? So 2 times 1/2, my apothem, 9.6569. This is what I'm supposed to be writing. Times my perimeter, which was 64. So when I add all of that up, so this and multiply all of this together, I end up getting 618.04. I need to add that to the 1408, and I find that the surface area is equal to 26.04 square feet. We will be doing a lot of those, so don't worry if you are feeling a little overwhelmed. We will do lots and lots more of those, but this is why it was so important that we learned SOHCAHTOA in our last chapter. All right, so now let's talk about cylinders. So a cylinder is a solid with congruent circular bases that lie in parallel planes. The height of the cylinder is the perpendicular distance between the bases. The radius of a base is the radius of the cylinder. In a right cylinder, the segment joining the centers of the bases is perpendicular to the bases. The lateral area of a cylinder is the area of its curved surface. The surface area of a cylinder is the sum of the lateral area and the area of the bases. Okay, so remember, lateral area never covers bases. So the lateral area of a cylinder, so this is a base, right? Here's my radius. Here's my height. And again, my height could also be on the inside. Okay, they are both perpendicular. And the bottom is a base as well. So the lateral area is the perimeter of the base times the height. My base is a circle, so the perimeter of a circle is 2 pi r and then times the height. So this is formula for lateral area of a cylinder. We'll be filling this in on our formula sheets. The surface area of a cylinder is the 2 pi rh plus 2 pi r squared. So let's look at some examples. And the lateral area and the total surface area. So first, lateral area equals 2 pi, the radius. So here my radius, 12, times my height. The height of the whole cylinder, 18. So when I multiply all of that, 2 times 12 times 18, I get 432 pi. I can leave my answer like that. That is called leaving it in terms of pi. Or if they want rounded, I multiply 432 by pi and I get 1,357.2 square meters. So then my surface area is equal to my lateral area, 432 pi, plus 2 pi, my radius, 12 squared. So this is 432 pi plus 288 pi. When I add those together, I get 720 pi square meters. That's in terms of pi. Or multiply that together, and I get 2,261.9 square meters. And it just depends on how they ask for their answer to be given. All right, last page of notes. On the lateral area and the total surface area. So again, I see that I have a cylinder. They're telling me that the diameter all the way across is 14. So if my diameter is 14, remember that diameter is all the way across, radius is halfway across, so my radius then is 7 meters. So the lateral area is equal to 2 pi, radius 7, height 28. So the lateral area is equal to 392 pi square meters, or I can multiply that all out and get 1,231.5 square meters. The surface area, my lateral area, 392 pi, plus 2 pi, my radius, 7 squared. So this is 392 pi plus 98 pi. So my surface area would be 490 pi square meters, or multiply that out, 1,539.4 square meters. All right, next one, word problems. An orange juice can is a cylinder with a base diameter of 7.2 feet and a height of 13.5 feet. Find the area of the label. So first I'm just going to draw that out. So here's my orange juice can, my cylinder. Okay. The radius, or sorry, they tell me the base diameter, so all the way across is 7.2 feet. The height is 13.5 feet. This is a huge can of orange juice. So if my diameter is 7.2, I know my radius is half of that. So my radius would be 3.6 feet. They ask the area of the label, okay? So think about a label when you buy a can. The label does not cover the bases, right? So the area of the label does not include the base. Does not include the bases. So what kind of area are they asking me to find? Therefore, we are looking for lateral area is what they're asking for. So lateral area is equal to 2 pi, our radius, 3.6, times our height, 13.5. So the lateral area, when I multiply all that out, I get 97.2 pi square feet. Or then multiply that through by pi, 305.4 4 square feet. That's the area of just the label. But again, this was a huge can, right? The can is 13.5 feet tall. Imagine going to the grocery store and trying to look out an orange juice can that's taller than you. All right, last problem. Find the height of a right cylinder. So I'm just going to draw the picture of this. So I have my right cylinder. It has a radius of 2.5. So the radius is 2.5 meters. Whose surface area, so they give me the surface area of 157.8 square meters. We are looking for the height, okay? So all we have to do is write out the formula, okay? So the surface area formula says 2 pi RH plus 2 pi r squared. I'm going to substitute, so I'm going to take this, plug in here. The radius, I'm going to plug in for my radius, and then I'm solving for the h. So I'm going to replace surface area with 157.08 equals 2 pi, my radius, 2.5. H, that's what I'm looking for, plus 2 pi, my radius, 2.5 squared. Okay? So over here I have 157.08. Here 2 times 2.5, that's 5 pi h, plus 2.5 squared, 12.5 pi. I'm going to go ahead and multiply through by pi. So 157.08 equals 5 pi, so this is about 15.71 h. 5 pi is about 39.27. Subtract 39.27 from both sides, so I get 117.81 equals 15.71 h. Now I just have to divide both sides by 15.71 to get h by itself. So my height is approximately 7.5 meters. All right, so that was section 12.2, lateral area, surface area of prism and cylinders, along with how do we find the apothem. I know that seemed like a lot, but it wasn't too bad.